Having known what oxidation number or oxidation state is in the previous video, it will be easy for us to balance the oxidation reduction equations. It is important to be able to balance oxidation reduction reactions. One method involves the use of oxidation states, and the other method, the one which is normally used for complex reactions, involves separating the reaction in two half reactions. We are going to do both methods here. In this video, we'll do both methods. So we'll start with the first one, which is balancing oxidation reduction reactions by oxidation states. What are the steps in doing this? There are 6 simple steps. The first step says, write the unbalanced equation. Number 2, determine the oxidation state of all atoms in the reactants and products. Show electrons gained and lost using tie lines. What do we mean by tie lines? Tie lines simply means, example, if you have A plus B equals to C plus D, you use the line like this. You say if this one has lost 2, this one has gained 2, you show. Okay. Fourth, use coefficients to equalize the electrons gained and lost. 5, balance the rest of the equation by inspection. Lastly, add appropriate states. Alright, having looked at the rules or the steps that will guide us in doing these questions, we'll look at case 1. Case 1 says balance the reaction between solid lead 2 oxide and ammonia gas to produce nitrogen gas, liquid water, and solid lead. So what are we going to do? The first thing first, we'll follow the steps. Step 1 says write the unbalanced equation. So we are going to extract the chemical formulae or the chemical equation from the word equation. Since we are given lead 2 oxide, how do you write lead 2 oxide? Lead 2 oxide. Oxygen 2, the 2 for oxygen and the 2 for lead will cancel. And you have this as a result. It is reacting with ammonia gas. How do you write ammonia gas? Like that. To yield what is produced? Nitrogen gas, liquid water, and lead, solid lead. Okay, wonderful. So what follows now? Step 2, determine the oxidation states of all atoms in the reactants and products. In the reactants, here it is positive 2, here it is negative 2. You already know what to do. In this case, hydrogen is positive 1, so positive 1 times 3 times positive 1 is 3. When it goes to the other side, to give us negative 3. Okay. We did this in the previous video of finding oxidation states or oxidation numbers. If you have no idea on how to go about this, going to go in the previous video, you're going to know everything and you're going to learn it from there. So the products, what is the oxidation number for this one? Since it is neutral, it is 0. This one, in this case, oxygen is negative 2, hydrogen positive 1. Okay, it is balancing. 2 times 1, 2. 2 minus 2, 0. Lead, it is in neutral, so it's 0. Okay, so what else? What else? We show electrons gained we show electrons gained and lost using tie lines. Okay, so how are we going to do it? If we look at this lead and that lead, what is happening between this and this? Here it is 0, here it is the positive 2. Meaning, this lead has gained. Just look at it. The oxidation number has reduced from positive 2 to 0, meaning it gained. When something has gained, the oxidation number will reduce. So, these 2 electrons gained. Okay? What else? What has happened to nitrogen? Okay, what has happened to, if you look at oxygen, it is all the same, -2, forget about it. Go to nitrogen. Here nitrogen, it's -3. Here it is 0. So what has happened to this? Okay, the oxidation number has increased from -3 to 0. It is increased because negative is smaller than 0. So meaning 3 electrons were lost for it to reach this 0 neutral stage. So what has happened? 3 electrons were lost. Therefore, it got oxidized. Okay, it has been oxidized because it has lost 3 electrons. This one has been reduced because it has gained 2 electrons. What is next? Use coefficients to equalize the electrons gained and lost. By the way, in a chemical equation, the electrons lost and gained must be equal. But in this case, this one has lost 3, this one has gained 2. How are we going to make it equal? We have a 3, we have a 2. What are we going to do? Multiply everything by the opposite number you're having. Here we have a 3, we'll bring this 3 here. Here we have a 2, we'll bring this 2 here. Is it balancing? Yes, because 3 times 2 it will be 6, 2 times 3 it will be 6. So the lost will be 6 and the gained will be 6. Is it making sense? Now let us use these same numbers to balance inside the equation. Okay, so nitrogen, here we are going to put a 2 because here we already have a 2. To balance everything, we're going to put this 2 here. So it will be 2. This 3, we're going to put it where there is a lead. Here we put 3 and here we put 3. My space is small. Hope you've seen what I'm doing here. So we put 3, 3. Everything here is 0. So lead 3, nitrogen 2, nitrogen 2, hydrogen. We have how many hydrogens this side? 6. Then this side, how many hydrogens? We have 2. So meaning we're also going to put a 3 here. Okay? We're going to put a 3 here. By doing this, our equation is balanced. Wonderful. So, you can look at these other examples. We have a task here. Okay, there's task 1. Task 1. The question says, specify which of the following are oxidizing or oxidation reduction reactions and identify the oxidizing agent, the reducing agent, and the substance being oxidized and the substance being reduced. Okay? We have those 3 reactions there. You need to tell which one has been oxidized, which one has been reduced, which one is the oxidizing agent, and which one is the reducing agent. Pause the video, do it on your own. You also do question 2, the same thing. So for question 1, we'll do it together. we'll do question 1. Okay. So we have copper, which is a solid, plus silver, which gives silver plus copper aqueous. Is this an oxidation reduction reaction? Let's check. What is happening to copper here? Copper is having 0. This side, copper 2 plus. Okay. What is happening to silver here? Silver has 1 plus. Here it is 0. I think oxidation is happening, oxidation reduction, because this silver here, it has a positive 1. This time it has 0. Copper had 0. This time it has plus 2. So this is an oxidation reduction reaction. The next thing, it is to identify the oxidizing agent, the reducing agent. Okay. The substance that is being oxidized and the substance that is being reduced. So since we'll start with copper. The oxidation number of copper has increased. Since the oxidation number of copper has increased, copper has been oxidized. Okay? Copper has been oxidized. Therefore, it is a reducing agent. It is a reducing agent. Since it is a reducing agent, it has been oxidized. The next one, silver. What has happened to silver? Silver, the oxidation state has reduced from positive 1 to 0. So meaning silver is reduced. Therefore, since it is reduced, it is an oxidizing agent. You do the same to question 1b, question 1c. Work those, try to work around them and find the answer. Okay. So now you can do these questions. Try to answer these questions from your knowledge, from what you've done, from what you've covered in the previous examples. Having looked at how to balance the redox oxidation reduction equations using oxidation states, we're now going to advance into balancing the oxidation reduction equations using the half reaction method. Okay, we're going to use the half reaction method. These half reaction methods are in 2 categories. There is the acidic one and there's the basic one. So the first we'll do, it's the acidic one. So the half reaction method for balancing equations for oxidation reduction reactions occurring in acidic solutions involves the following steps. Step 1, write separate equations for the oxidation and reduction half reactions. Number 2, for each half reaction, A, balance all the elements except hydrogen and oxygen. B, balance oxygen using water. Balance hydrogen using hydrogen. And D, balance the charge using electrons. So if necessary, multiply one or both balanced half reactions by an integer to equalize the number of electrons transferred into 2 half reactions. This is just a reminder that the electrons lost should be equal to the electrons gained in a chemical equation. Step 4, add the half reactions and cancel identical species. Number 5, check that the elements and charges are balanced. Then you're done. So we'll quickly go into an example. Example 1 reads, potassium dichromate is a bright orange compound that can be reduced to a blue violet solution of chromium ions. Under certain conditions, potassium dichromate reacts with ethyl alcohol, or ethanol as follows. We are given an equation, and the question says balance this equation using the half reaction method, the acidic half reaction method. It's very simple. So what we are going to do is copy the equation and start following the steps. So we have the equation which has hydrogen plus plus pardon me, I'm leaving the state symbols. To economize my space, but don't leave out state symbols. Okay, so we have this equation. So now we can follow the steps. We can follow the steps because they are guiding us. We write separate equations for the oxidation and reduction half reactions. But how are we going to know this is oxidation and reduction half reaction? It's going back to oxidation numbers or oxidation state. We'll go back. What is happening here? What is the oxidation state for this hydrogen? It is positive 1. Oxidation state for this. What is the oxidation state for this one? So what we're going to do is we bring this one alone. The whole compound, it's equals to -2. And we know that we have 2 chromium ions. It is a revision in case we didn't understand how to find oxidation numbers. So chromium, since we have 2, we don't know the oxidation state. We'll say plus oxygen. There are 7. And the oxidation state is -2. I'm not getting this -2. It is given in the rules for oxidation number that oxygen in its compound has a -2 oxidation state, which is equals to -2. So 2x, this by this, it is -14. So -2, -14, when it crosses the equal sign, it will be +14. So meaning 2x is equals to 12 divided by 2 divided by 2. So meaning x is equals to 6, +6. So meaning each chromium ion has a +6 oxidation state. As simple as that. So meaning +6, oxygen -2. What is happening here? The same thing. This whole compound has a sum of 0 because it is neutral. It's not having any charge. So it has a sum of 0. We have how many hydrogen molecules here or atoms? We have 6. 5 plus 1, 6. The charge is +1. Then oxygen, we know that oxygen, it has a -2 in its compound. So -2. I've put a -2 because positive times negative, it's negative. Plus, how many carbons? We don't know the oxidation state. So we're going to say 2x, which is equals to 0. This will be 6 minus 2 plus 2x equals to 0. 2x will be equals to -4 over 2 over 2. So x will be equals to -2. So carbon has a charge of -2. Therefore, -2, +1, oxygen -2, hydrogen +1. When you add this, they will total up to 0. Here it is direct. We use the ion, the charge. So it is +3. Okay? Carbon, oxygen here, it's -2. Carbon, +2. positive 4. Sorry. We did this example, so I'm just getting the same answers. We did the example in the previous videos of oxidation number. Here, oxygen negative 2, hydrogen positive 1. So now we want to identify the reduction reaction and the oxidation reaction. Let us counter check. Forgot about the hydrogen and the oxygens. If you look at this chromium, it has 6. This side it has 3. So meaning the oxidation number has reduced. So this is a reduction reaction. Reduction reaction because it has reduced. So a reduction reaction, we have this one. Which is giving us this. Good. How about oxidation reaction? The oxidation reaction we're having, it's this carbon. It is from negative 2 to 4. So meaning this to this, it's oxidation because the oxidation number has increased. So C2H5 OH to this, whatever is happening here, it's oxidation. Okay, so we've come up with half reactions. The first step, it says balance all the elements except hydrogen and oxygen. Balance for each half reaction, balance the elements. How many chromium are we having here? We have 2. This side 1, so we're going to put a 2 here. It is balanced. Remember, we're told except oxygen and hydrogen. We'll go to the next one. How many carbons are we having? 2. This side 1, so we're going to put a 2. Hydrogen, forget about it. Oxygen, forget about it. We've balanced. We go to step B. Balance oxygen using water. Balance oxygen using water. So what are we going to do? Where there's no oxygen, we are going to add the water. In this first equation, there's oxygen here. How many? 7. So we're going to add 7 molecules of water. 7 molecules of water. Meaning, how many oxygen this side? 7. Okay? There are 7. This side, 7. Even here, let us balance the oxygen. How many oxygens are we having here? There's 1. Here, 2. So which side are we going to add water? The side which has less oxygen. So we're going to say, since here is 1, here actually there are 4. 2 times 2. There are 4. Here we have 1. Meaning here, we're going to add we want to balance the oxygen. You're going to add the 3 molecules of water so that we have 3 oxygen and 1 here, which will give us 4. So this side we have 4 oxygen, this side 4 oxygen, 7 oxygen, 7 oxygen. All the elements are balanced except hydrogen. How many hydrogens are we having this side? We don't have. This side, 7 times 2, 14. So since there are 14 hydrogens here, we're going to add hydrogen ions this side. And how many? 14. So we're going to add a 14 here. Hope you're following. Hydrogen, we are done. We are on step C, balance hydrogen using H ions. This side, how many hydrogens are we having here? 3, 6, plus 5, 11, plus 1, 12. There are 12 hydrogens this side. This side, 0. So we're going to say 12 hydrogen ions. We're almost. D, balance the charge using electrons. Balance the charge using electrons. We'll start. If you look at this first one, The charge here is positive 1. Positive 1 times 14, it is positive 14. The charge here, it is negative 2. So meaning 14 minus 2, the charge here ought to be positive 12. Let's check the charge here. On the other side, the charge here, it is positive 3. So 2 times this one, it will be positive 6. The charge here, it has no charge, it is 0. So meaning this side we have 12, this side we have 6. So what are we going to do? When electrons are added, meaning this charge will reduce. For example, if we add 6 electrons here, meaning this charge will reduce to positive 6. That's how we balance charges. So we balance charges by adding. We balance charges by adding electrons. Therefore, what are we going to do? To balance this one, you're going to add 6 electrons plus 14 hydrogen ions plus this that we have, which will give us 2 plus 7 water. Good. Are the charges balanced? They are balanced because now we have this, which is 14 plus 14. Here we have negative 2, which is 12. 12 plus this number of electrons, the negative, meaning we are subtracting 6 electrons, will remain with 6. This side we have 2 times 3, which is 6. It is balanced. We'll go to the next one. The next one is this one. Let us count the charges. This one, it has 0 because it has no charge here. This one, 0. This one, 0. This one has 1, the positive 1. So positive 1 times 12, it is, so meaning in this case, we have 12 electrons. What are we going to do to this one? Since here we have 0, here we have positive 12. Alright, so what we'll do, it's to add 12 electrons this side. We're going to add 12 electrons this side so that it balances. So we're going to say plus 12 electrons. So that this 12 plus this 12 gives us 0. So that it balances with this 0 this side. Don't forget that we balanced the reaction. There's a paper I'm having here. So what I'm going to do is to fold this part so that I bring this part here. We continue with what we are doing. We have an oxidation reaction and we have a reduction reaction. Okay? Everything is balanced. Everything is balanced. What is the next step? If necessary, multiply one or both balanced half reactions by an integer to equalize the number of electrons transferred. So now, the number of electrons lost should be equal to the number of electrons gained. Here, this is oxidation reaction, meaning it has lost. This one is a reduction reaction, meaning it has gained. Are the numbers equal? Where do we check? Here we have 6 electrons gained. Here we have 12 electrons lost. So we need to balance this 12 and this 6. What are we going to do? What are we going to do to have 12 here? Since the biggest number is 12 electrons lost. So meaning here we also need to have 12 electrons gained. What are we going to do? We are going to multiply this whole thing by 2. So if we multiply, we are going to have 12 electrons. Okay? 12 electrons plus 2 times 14, 28 hydrogen. 2 times this one, it will be 2, which is equals to 2 times this one, it will be 4, plus 2 times 7, it will be 14 water molecules. Okay, we've now balanced. What am I going to do? Since it is balanced, I'm going to fold this paper also, don't get confused. This is now unnecessary. The one which is on top is unnecessary. We're moving 2 equations together. I'm putting it here now. We have these 2 equations. The electrons lost and the electrons gained are now equal. So what are we going to do? We are going to add all the reactants together and all the products together. But since in my case I'm not having enough space, we are going to cancel in advance we're going to check the species which are same, which are identical, and we're going to cancel them. Okay? How do we cancel? We only cancel those from opposite. We only cancel reactant and products, because when the other one crosses the equal sign and comes this side, they will cancel. The sign will change. So, in this case, this will cancel with this, because they are the same. Okay? What will happen to this reactant and this product? This is 28, this is 12. When this one comes this side, since they are like terms, it will be 28 minus 12, for which this will cancel, and here will remain with 16. Remain with 16 hydrogen ions. What else will cancel here? Water. This is a reactant. When this water comes this side, actually this one will follow this one to avoid negatives. So this will cancel and it will subtract this one. We're going to remain with how many water molecules? 11. Okay? Now, we can write the whole equation together now. So what are the reactants? 1, 2, 3. We have CH5O plus 16 hydrogen molecules plus hydrogen ions plus 2 chromium negative 2, which is equals to the reactants are done. We've added all the reactants. The products we're having, it is 2 plus 4 chromium ions plus they are now 11 water molecules. Is it balanced? Let us counter check. This whole compound, it's 0. This whole compound, it's 16. This whole compound, it's negative 4. 16, negative 4. So 16 minus 4, it is 12. Let us check this one. This is 0. 4 times 3, it is 12. This one, 0. So 12 is equals to 12. So meaning it is balanced. And this is how we balance using half reactions for an acidic condition. The next thing we'll do is balancing using basic medium. So the same procedure that we use to do the half reaction method for balancing equations using basic medium, it's the same. Actually, it will be just a bit of an advance from where we ended. So this second method is a continuation from where we ended. The steps are given. So the steps, if we look at these steps, step 1 says from where we've ended in the acidic medium, The second thing we do, it is to both sides of the equation, this equation that we had, from both sides, we need to add hydroxide ions. These hydroxide ions should be equal to the hydrogen ions we have. So since we have 16 hydrogen ions, we're going to add 16 hydroxide ions, 16 hydroxide ions this side. Step 3, form water on the side containing hydrogen ions and hydroxide ions. So meaning, when you add hydroxide ions this side, you're going to add those hydroxide ions with these hydrogen ions to have water, so that by the end of the day, we cancel the water which is here and the water this is here. Here we won't have water because the hydroxide ion will remain alone without any hydrogen ion. We don't have any hydrogen ion here. So no water will be formed, but we already have the existing water this side. So that's how the water molecules will cancel. Then you check the elements and charges if they are balanced. That's about method 2. So we'll do a different example so that you finish this example we did in question 1 in method 1 to see if you're understanding what we are doing here. Here is an example. The example says balance this equation using the half reaction method, using basic medium. So we have, you're given this equation, okay, plus iron 2 all right. Following the rules that we did in the previous video under oxidation numbers or oxidation states, it's clear here, since we have ions here it's direct. We have this number or oxidation state for iron. We've already seen that here the oxidation number has increased, meaning we have an oxidation reaction happening here. This is an oxidation half reaction already. If we go to this one, we'll go back to calculations. This alone, it's plus 3. Okay? Plus 3. Then, what is happening here? How are we going to find the oxidation number for these elements? We know that the total is 0. So, we have 7 oxygen atoms. The oxidation number is -2. Not this -2, but the -2 that oxygen has in its compounds. Plus 2, since we don't know the oxidation state for this element, we're going to put x equals to 2. This will be 2x equals to, when this crosses the equal sign, it will be positive 14 over 2 over 2, meaning x is equals to positive 7. Therefore, this is positive 7, this is -2. As clear as that. So meaning, which one will be the oxidation half reaction? It will be this for iron. This to this will be oxidation, because the oxidation number has increased, meaning oxidation is happening here. This, from this to this will be reduction. Why? Because the oxidation number has reduced from positive 7 to positive 3. Okay? This alone is reduction. So now we're going to have the half reactions. Oxidation half reaction will be iron 2, which will give us iron 3. Okay? Then the other one will be reduction half reaction, which is this, which gives wonderful. So we'll follow the steps that the same procedure that we used in the first example of the acidic medium. We balance these elements. We have one ion, one ion. Here we have two, here we have two. It is balanced. The next thing to balance is oxygen. Are we having oxygen here? We don't have. This side, we don't have. We forget about it. Are we having hydrogen here? Nothing. Here, nothing. We come to this one. Oxygen here, we have 7. This side, we don't have. So we are going to have, what do we do to balance oxygen? It is to add water. So we're going to add 7 molecules of water for us to have 7 oxygens. Is hydrogen balanced? No. We have 14 hydrogens here. This side we don't have. So we're going to add the 14 hydrogen ions. Hydrogen balanced, oxygen balanced, the other elements, compounds, molecules balanced, even here balanced. What is remaining? The electrons. Are they balanced or not? This side, 2 electrons. So here we have positive 2, here we have negative 3. How are we going to make this to be equal? It must be 2 or 3. So we are going to add an electron here. If we add an electron here, an electron plus 3, it will remain to 2. It will remain, we'll have 2. So we've balanced here. How about this side? What is happening here? How are we going to balance? Here we have 14. We have this positive, meaning positive 14. Here we have negative 2. So 14 minus 2, it is 12. This side, we have 3. 3 times 2, it is positive 6. 0. So we have 12, we have 6. We need to make this side to be 6 or to make this side to be 12 also. We can't, when we add 2 here, or we add 6, when electrons are added, it will make this number to be reduced. So when adding, we add to the side which has a lot of electrons. So since we have 12 here, we're going to add the 6 electrons. Okay, so 6 electrons were added to this part of the equation so that we balance up. Now everything is balanced. What is remaining is the number of electrons lost. Since here electrons were lost, are the number of electrons lost equal to the number of electrons gained? It is not. Why? Because here we have 1 electron, here we have 6 electrons. What are we going to do? We are going to multiply this equation by 6 and this equation by 1 so that we balance up. Okay? So how is this going to be possible? This will only be possible by multiplying whatever is in here by 6. So we'll have 6 ion this 6 ion. Okay, this will be 6, this will be 6, and this will become 6. Okay, I'm coming up with something here. So we've balanced, putting a 6, 6, 6, everything is balanced. So we've balanced the electrons. What is remaining? We add and cancel what is appearing on both sides. Okay, so if you look, let me just add. So we have this iron 2 plus. The next one is plus 6 electrons plus 14 hydrogen plus this, which gives, we get again whatever is here, 6 ion 3 plus 6 electrons plus 2 plus 7 molecules of water. Wonderful. So I've put everything in one equation. What is on both sides? What actually happens here, it's this can come this side, so it will be 6 electrons minus 6 electrons, which will be 0. That's the reason why we cancel out these. This comes this side, they can't cancel, they cannot cancel because we have 3 plus and we have 2 plus here, so they cannot cancel. What is remaining is what is in this equation. Now we're not done. If it was an acidic medium, this was going to be correct just like this. Now the question is asking us to balance this equation using half reaction method basic medium, meaning basic medium where we need to add hydroxide. So from where we've ended, what we're going to do now is to add hydroxide to both sides using the number of hydrogen ions. How many hydrogen ions are we having? 14. So we're going to add 14 hydroxides this side, then we bring whatever is here plus 6 ion 2 plus 14 hydrogen ions plus whatever having here, which we use. Even this side you're going to add 14 hydroxide ions plus 6 ion, this ion 3 plus 2 chromium ions plus 7 water molecules. Apologies, my space is not enough. So now what will happen? We have 14 hydroxide ions, we have 14 hydrogen ions. Hydrogen and hydroxide will add to make water. So in this case, we'll have 14 water molecules plus these two adds up to make this one, because that is the goal for us to add hydroxide, it's to come up with water molecules, plus this, which will give us 14 hydroxide plus 6 ion 3 plus 2 chromium 3 plus 7 molecules of water. Okay, so all right, so now this side we have 14 water molecules, this side we have 7 water molecules. When this 7 water molecules, when they come this side, they cross the yield sign, they'll have a negative sign. So 14 minus 7 will remain with the 7. So this will go and we'll have 7 water molecules followed by 6 ion 2 plus this, which gives 14 hydroxide plus 6 ion 3 plus 2, and this is our answer in basic media. That's all. If you want, you can balance, you can check the counter check. 2 times 6, 12, minus 2, 10. 6 times 3, 18. By the way, this is negative since it is hydroxide. Good. Hydroxide should be negative. So 6 times 3, 18. 2 times 3, 6, plus, minus actually, minus 14. It will give us 10 also. So 10, 10. Everything is balanced. Okay. So this is where we end. This is where I end. You can check for questions. Try to do them. Work them out. You'll be able to solve them using this same concept. Bye.